Let's take a look at section 10.5, angle relationships in circles. And so, as it says, we're going to look at angles inside of a circle. And you're saying, how did that happen? Well, let's take a look at the first theorem. Theorem 10.14 says the tangent and intersected chord theorem. If a tangent and a chord intersect at a point on a circle, then the measure of each angle formed is 1/2 of the measure of the intercepted arc. So these angles are formed because we have a tangent line, and then we also have a chord. So let me go ahead, I'll highlight right here. A is our tangent line. A to B right here happens to be the chord. And so what that happens here is we now have two arcs. Okay. And if I take a look, I'm going to highlight arc A to B. And you can see that there's angle 1 that's formed. Okay, so angle 1 right here, or the measure of angle 1, is equal to 1/2 of the arc A to B. Angle 2 right here is going to be equal to 1/2 of arc BCA. That I'm going to go ahead and highlight right here in green. All right, so there is our two equations, both pretty much the same, finding angle 1 and angle 2. So we have the tangent and intersected chord theorem. Very important to know. In our next concept, we have intersecting lines and circles. Okay, so it states that if two non-parallel lines intersect a circle, there are 3 places where the lines can intersect. They can intersect on the inside, as you can see right here in the middle diagram. They can be on the circle, which is the diagram to the left, and they could also be outside the circle. Okay, so two non-parallel lines intersect a circle. There are 3 places where the lines can intersect. And we'll dive more into that in the theorem 10.16. So next up, let's take a look at theorem 10.15, the angles inside the circle theorem. Okay, so it states that if two chords intersect inside a circle, then the measure of each angle is 1/2 the sum of the measures of the arcs of the arcs intercepted by the angle and its vertical angle. So what does all that mean? Right here in the diagram, I look at angle 1. Okay. The measure of angle 1 right here is going to be equal to 1/2 the measures of its intercepted, of the arcs intercepted. So the arcs intercepted right here for angle 1 happen to be D to C and A to B. So if I take 1/2 of arc DC plus arc AB, then that'll help me find angle 1. If I want to find angle 2, right here, the measure of angle 2 is going to be equal to 1/2 the intercepted arc, which is A to D, plus B to C. Now, if I happen to have found angle 1 first, I could find angle 2 quite easily because they are a linear pair. So you wouldn't necessarily have to do both at the same, do it twice. If you could find one of the angles, then you could find the other one because they are a linear pair. Moving along. So here we have theorem 10.16, outside the circle theorem. So if a tangent and a secant, two tangents, or two secants intersect outside a circle, then the measure of the angle formed is 1/2 the difference of the measure of the intercepted arcs. Here's the big thing that I want you guys to realize, that all of these, in these 3 examples, they're all fairly similar. How are they similar? Because if we take a look at the equation right here, I want to highlight, and I want to put right here, for the first one, measure of angle 1 is equal to 1/2 of measure of arc BC. That right there is the outer arc. The measure of arc AC is the inner arc. And that's in relation to the in relation to the angle. So once again, I'm showing you right here. B to C is the outer arc. A to C right here. I'll highlight that in blue. That's your inner arc. So the measure of angle 1 is equal to 1/2 BC minus AC. Now don't forget, this one is minus, all right? And then so outer arc minus inner arc. Taking a look at angle 2 once again. Right here, angle 2 is over here on the left side, and then the outer arc is PQR. And guess what? In the equation right here, we have arc PQR, which is the outer. We have arc PR right here, which happens to be the inner. So the measure of angle 2 is equal to 1/2 the measure of arc PQR minus the measure of arc PR. And then we're going to still see the same thing right here. This time we've got ourselves our two secants. And so the measure of angle 3, we have XY is the outer. And then we have right here WZ, that is the inner. And so that's the measure of angle 3, equal to 1/2 the outer, XY, minus the inner, WZ. Okay, so all three, whether you have two tangents, two secants, a tangent and a secant, you take the outermost arc minus the innermost arc in relation to the angle. Early on, there was the mention of the circumscribed angle. I didn't talk about it, but we're going to mention it right here. Remember, a circumscribed angle is an angle whose sides are tangent to a circle. Okay, so remember, if we're talking about circumscribed, it's going to be on the outer side. So if the angle is circumscribing a circle, the angle will be on the outer part of the circle. And that's pretty much what is being stated right here. A circumscribed angle is an angle whose sides are tangent to a circle. Now the reason why that's important, because right here in Theorem 10.17, in the circumscribed angle theorem, it states that the measure of a circumscribed angle is equal to 180 minus the measure of the central angle that intercepts the same arc. Okay, so if we take a look at the angle right here, angle ADB, what they're saying is that if you take 180 and then minus the central angle, and the central angle right here is angle ACB, then you'll be able to find what angle D happens to be. So 180 minus that central angle. So you'll see that they are inside of one another. So let's see how we could put all this stuff together. Here we go with the extra practice right here. Taking a look at exercises 1, 2, and 3, all based off of this diagram. Okay, so it starts off. It says CD is tangent. Line CD is tangent to the circle. So then we can go ahead and use the theorem that we just learned right here, which was Theorem 10.14, the tangent and intersected chord theorem. So if I'm taking a look at angle ABC, okay, I'm trying to figure out this angle right here. That one's not too hard, okay, because think about it. Line CD is a straight angle, 180. And I know that right here, angle ABD is 70. So don't forget, we have ourselves, linear pair. So if I take the angle ABC plus angle ABD, that's equal to 180. So ABC, we'll put X plus 70 is equal to 180. This angle ABC is equal to 110 degrees. So I'll go ahead and fill in 110 right over here. So now that leads us to finding the measure of arc A to B in number 2. So arc AB, I'll go ahead and highlight that in red. Or we have our theorem where the angle, which happens to be 70, is equal to 1/2 the measure of the arc, or arc AB. Okay. So in order for us to get the measure of arc AB, I'm going to go ahead and need to multiply both sides by 2 to get rid of that 1/2. And so the measure of arc AB, 2 times 70, that's 140. So that measurement of the arc, I'm going to go ahead and put on the diagram, is 140 degrees. So now the rest is saying, all right, how do I find the measure of arc AEB? Okay. So the arc AEB, I want to go ahead and highlight that in yellow or gold. And so let's repeat the same process. I know what the angle is. The angle ABC is 110. So that's going to be equal to, we have 1/2 the measure of arc AEB. So repeating pretty much what we did in number 2, multiply both sides by 2 right here, and the measure of arc AEB is equal to 220. Okay. I'm showing it to you this way just to make sure you know how to use the equation. Okay. But what I could have done here is this. Knowing that the entire circle is 360 degrees, and I already have one part of it, if I take 360 minus 140, that'll get me arc AEB as well. Okay? So if you think big picture, hey, I know the entire circle is 360. If I take 140, that'll get me my 220 as well. All right, so you could piece things together. Arc addition postulate, knowing that, hey, the entire circle is 360. Let's go next up to number 4 and 5. So it looks like right here we've got a point outside the circle. Excuse me. We have a secant and a tangent. So let's see what we could do here. They give us some information. It says that angle or arc ABD is 220. So A, D, and all the way right over here to B is 220. Okay, so that's good. They tell us that the measure of angle B right here is 21. So angle B is 21 degrees, and let me go ahead and put that right here. So we want to find the indicated measure. The first one right here is the measure of arc A to B. Okay? So remember, in order for us to find the measure of arc AB, this one's pretty simple because they gave us right here the remaining arc, right? We know that A to B, I'm going to go ahead and highlight that in green right here, is some unknown amount. But remember, we have ADB, which is 220 degrees of this circle. So remember, the whole circle is 360. That's going to be equal to 220 plus the measure of arc AB. It's all about setting up the equation. So that's why I'm trying to show you right here. First off, set up the equation. Let's solve it out. We'll subtract 220 to both sides, and the measure of arc AB happens to be 140 degrees now. Okay, so there we go. We got 140. We got ourselves a full circle. So now we got ourselves we're trying to find the measure of angle ACB. Okay. There's some things you got to remember from before, right? So what I see is we have angle B, which is 21. And that 21 right here, or this angle, we've got ourselves this inscribed angle. Right there. And that inscribed angle will help us find our arc measurement right here. And I'm going to put in purple. Okay, so I'm going to try to figure out what is the measure of arc AD. So let's take the measure of the angle. Hold on. So we'll take the measure of the angle, which is 21 degrees, and that's going to equal to 1/2 the measure of arc AD. And so when I go ahead and solve for AD, multiply both sides by 2, the measure of arc A to D ends up equaling 42 degrees. So now we know right here we've got ourselves 42. So why is that a big deal? Now that leads us to another theorem that we had learned in this chapter, or this section so far. And we had talked about the remember, angle ACB is on the outside of the circle. So we have the outside circle theorem. And so putting all of that together right here, I'm going to go ahead and rewrite this and say that the measure of angle ACB is equal to 1/2. And then remember right here, we talked about the outer arc minus the inner arc. Okay, the outer arc right here from this pertaining to angle ACB, the outer arc is 140. The inner arc is that piece that we just found minus 42. And so when we go ahead and simplify this, we can go ahead and get our answer. We have 1/2, and then we have 140 minus 42. That'll get us 98. And when you take 1/2 of that, that ends up becoming right here your answer of 49 degrees. And that is the measure of angle ACB. So there are several ways about going about this problem, but I found that this one, hey, it works. And then we also get to use the outside angle theorem. Okay? Next up, let's take a look at number 6. So right here, we've got an angle on the inside, and then we also have 2 intercepted arcs. Okay, so let me go ahead and highlight this. We got D to C and A to B as intercepted arcs, and angle X is in the middle. Okay, so we have our equation. We mentioned in 10.15 the angles inside the circle theorem. That angle X is inside the circle. And this measure, angle X, is equal to, according to our theorem, 1/2 the measure of the intercepted arcs. This time we need to add the 2 together. We've got 92 plus 50. And so there is your setup. Go ahead and put things together, we end up with 1/2 of that end up being what, 142. And if you take half of that, you'll end up with 71. So the measure of angle X is 71 degrees. If we take a look at number 7 next, we can do the same exact thing. However, hey, I don't know what this angle is. Right? They give us 2 arcs. Okay? So what that'll allow us to do is we could figure out one of these angles, right? The angle in between. And actually, instead of making that X, let me change that to like Y. So if we use our equation, we have angle Y is equal to 1/2. We have 97 plus 35. All right, so we could figure out what that angle now it happens to be. We get 132, and you need to take half of 132, and Y is equal to 66. Okay? So if I know that this angle is 66, remember, we have 2 angles right there, and they are a linear pair. So the next step is, well, I could take 66 plus the second angle, which is 5x plus 14, and then set that equal to 180. All right, so this will lead us to our second answer. So we got 54 is, I'm sorry, I don't know where I got 54. We have 5x plus 80 is equal to 180. 5x is equal to 100 when we subtract 80 to both sides. And then when we divide both sides by 5, x is equal to 20. And there you have your answer. We could also have figured out this problem a different way. What I could have done, let me show you what else, is, look, I could figure out how much these 2 arcs happen to be, C to B and A to D. Remember, in order for us to use our theorem right here, like we did in number 6, and we just did right here in number 7, I don't necessarily have to know the exact amount of each arc. What I do need to know right here is how much are those intercepted arcs. Okay, the whole circle is 360. So if I take right here 360 minus 97 minus 35, I get 228. Okay, these two, CD plus D to A, is 225 or 228. So what could I have done? I could take 5x plus 14, set that equal to 1/2 of 228, and then you would have been able to solve the problem as well. Okay, so either way works. It's choose your own adventure right there. Some classic books from my childhood where you get to read a book or choose which page you want to go to depending on how you want to read the story. And then you could actually make it really short too sometimes. The only problem is that teachers wouldn't allow you to choose that book for book reports because you could make it too short or it wouldn't be a very long novel depending on your adventure. But I digress. Let's take a look next up at number 8. Okay, so right here, it looks like we're going to take a look at theorem 10.15. All right, we have an external angle, or all right, an angle on the outside, and we have ourselves our 2 arcs. All right, the way we take a look at the arcs is we've got outer arc and inner arc right here. So the measure of the angle, now this time we don't know what the outer arc is, so we're going to put that in our equation. So we know what the measure of the angle, that measure is 38. That is equal to 1/2. And let's go ahead and put the outer arc being x. And then don't forget minus the inner arc, which is 72. And so all we need to do now is go ahead and solve for x. We'll start off, multiply both sides by 2. Let's get rid of that 1/2. You could distribute that if you'd like. I'm not a fan of that in this situation. I'd rather just get rid of it, because then you're going to have to eventually multiply both sides by 2 anyways. So this at least hopefully reduces some of the work, and we now have 76 is equal to x minus 72. All right, so then we go ahead and add 72 to both sides, and you should have yourself 148. And right there, we just found the measure of angle x. All right, just like that, pretty simple. We have one last problem right here. We got same thing. We now have, we've got an angle, we've got the outer arc, and we have the inner arc. Now there's some algebra in this one. That's what makes this one a little more challenging. So let's set this up. The setup right here will be 28, and that's going to be equal to 1/2 the measure of the outer, which is 4x plus 8. And then we've got to be careful right here, because actually let me use double parentheses, because we have one term and then we have minus the inner term right here, and we have 3x plus 2. And you're saying, well, why am I doing that? Well, right here, the problem is the setup is typically pretty easy. The hard part is right here, making sure that, hey, when I subtract, I've got to make sure that I distribute or change the signs inside of the 3x plus 2. So if I go ahead and rewrite this, we got 4x plus 8, and it should be minus 3x minus 2. And once you have that set up, then you'll be able to get the correct answer. So let's begin to simplify all of this. We got 1/2, and then 4x minus 3x, that's x. 8 minus 2, that gets us plus 6. Just like before right here, I like to go ahead and multiply both sides by 2. So now I have 56 is now equal to x plus 6. And when we subtract x to both sides, we have x is now equal to 50. There you go. Finish this section. We found x right here. All right. Hopefully you were able to learn section 10.5, and I appreciate it. If you can go ahead and give me a like, if you could subscribe, hey, and leave a comment if you have any questions. All right, I'll see you later.